I think
Are
we're
we-
recording. Can you tell?
Yep, I got the red
Lemon
light.
heads. What do you call yours?
Dealmanites, Deal Dogs.
Welcome to another exciting night of math. Only it won't be night when you view this. Mr. Dealman and I just spent how long, Mr. Dealman?
I'd say
Too long.
an hour or so.
Yeah. We're trying to make this work, guys. We're so sorry that this process is just, I know it's not perfect, but we're trying to do our best. So you can see that table should look familiar to you because I'm pretty confident we gave that to them yesterday.
Yeah.
Google Doc, right?
Yep.
And so we created this really great message. Hi, gang. One of your problems in the book was to take a message and code it. Well, hopefully we did our math correctly, or we read this table correctly. 17, 18, 16, 10, 23, 16. It would be these 6 letters coded.
Mm-hmm.
Then I think, didn't our book say this isn't a code, this is the message. We're going to code it by, so no one knows what we're really saying. We're going to add 16 to everybody.
Right.
So say Mr. Diema wants to send me a secret message, hi gang, and he makes this code. He adds 16, and then he tells me, hey, Lemonhead, the decoding is take away 16 from every term that I gave you, and then look at the table.
Mm-hmm.
And then I would know that his secret message was right back where we started at hi gang. Did we do good on that, Mr. Dealman?
Yeah, it actually went a lot faster than I anticipated, but that is pretty much, since they've seen it, it's exactly like what they did in Investigation 1.
So then they're probably wondering, what the heck, why are you doing that? Because we're trying to give you a context of this great big item in math land called an inverse function.
Mm-hmm.
And that's a topic that takes a little grit. So the conceptual idea here is just you're coding a message and then you're decoding it.
Mm-hmm.
I think we're doing pretty well. So notice the code message was f of x. The decoding was called g of x. I like to think of these as undoers. What this one did, this one undid.
Mm-hmm.
Them things in real life are called what, Mr. Dielman? What kind of functions?
Those are inverse functions, and if you couldn't read it, it's in all caps. That's what you should be focusing on. Inverse. So we would say, in this case, g of x is the inverse function of f of x. And there is some special notation in Mathland that we use in the next line. In the notation for an inverse function, I think you guys should hopefully be able to see the arrow that Mr. Lemon's pointing at, but the inverse, you might have seen this, you hopefully have seen this with trigonometry, right? When you do inverse sine, inverse cosine, when you're trying to use the lovely trigonometry to find missing sides. To the power of -1 stands for inverse. So we would say the inverse function of f of x is going to be f to the -1 of x. So to connect it, g of x would be equivalent to f to the -1 of x, our inverse function.
That was I compliment you. That was a really good connection. I didn't think of that before. The inverse sine and inverse cosine.
I only remember just because I just got done teaching trig for core 2, so yeah, it's fresh in my mind.
That's a good catch. That's a good connection. So guys, it looks like a -1, but understand this gets a little confusing, and I don't even know sometimes if you should bring up confusion, because then you probably will fall into the trap. But from core 1 days, please remember 2 to a -1 is a half, 1 over 2. That's an exponent. Don't think that f to a -1 is 1 over f, because
Right.
that's not the same thing. This is a function notation. It's the inverse function, not the reciprocal. Something like that.
Yeah, that was good. That was important.
Yeah. So what this whole business did, we started out with 17. We coded it to 33, then the uncoding it back to 17. And we did that for all of the points. Yeah?
Mm-hmm.
If we think of this as a set of ordered pairs, because think, guys, if we're in function land, functions have an input, an x value, and an output, a y value, or a f of x value. So if we look at this notation, we took the 17 and our code function coded that 17 to 33. That's called an ordered pair. That's a function notation scenario. The decoding function then took this 33 and put it back into 17. So this decoding function, f inverse of x, would take the 33 and turn it back to 17. The point we're trying to make by doing this is this undoing idea.
Mm-hmm.
Notice, please, that if this is the function and this is the decoding function, all the decoding function does is make the y turn into an x. The x becomes the y and the y becomes the x. That's a good little jingle when you're talking about an inverse function. X becomes y. The ordered pair switch. 1733 becomes 3317.
We've got notation for that too.
Down
If
here.
you,
Talk.
yeah.
Yep.
Sometimes it's better in words, but there is notation that we can use to represent it.
Which is right here at the bottom. What
Yep.
he's referring to is here's f of x. That f of x function is going to turn it into a y. We take that y, we put the y into the f inverse function, and it magically turns it back into an x. Oh, it's so easy when you've done it for 400 years like me, but when you're first seeing it, I know it can be a little dicey. Anybody have any questions? Oh, wait, what questions do you have? You'd think by now I'd get that right, but that's old age. You got any questions on your end? Any in your class? You're supposed to look left and right now, Mr. Dealman. There you go. That's what we've done every other video. Maybe we'll be consistent. What else, boss man, do you think we got to add to this? It's a pretty good discussion so far, but are we missing anything?
Well, I mean, this is an example of an inverse function, but that, I mean, we don't live in a perfect world. So not every function is going to have an inverse function. So I feel like we should give an example.
You had the greatest segues. That's awesome. So all I have to do now is click this arrow. That's so good. That is so good. You guys don't know how talented this young punk is. Because that was our next point. Not all functions have an inverse. Not all functions have an undoer of themselves. And I know that that might be, at first thought, hard for you to grasp. What do you mean it wouldn't have an undoer? It was plus 16, now you're minus 16. How hard can that be? You'd probably say if it was minus 16, you'd add 16, and you'd be right. But it's a little bit more complicated than that. So, the question that we need to think about today is, I guess I can't do anything, Mr. Young. I forgot that this is a PDF.
Well, you got your pen. You can underline it.
This, when I was in school and I had to make a long fraction bar, I used a ruler. I could bring in my 9th grade notebook and I could prove it to you all that I used a ruler when we were doing these big wacky fractions. I used a ruler to make my fraction bars.
I could have used that in college.
Loser, but that's what I like to do. Okay, so there's the question, gang. What functions have an inverse, and how do you tell? A follow-up question, which we didn't type, is once we know it has one, how do you find it? But that's for a later discussion.
For sure.
So this is good terminology. Let's keep things simple. At least we said it.
Mm-hmm.
We don't know if it really will be, but it looks good.
We're doing our best.
Subliminal messages right now. So we aren't getting very creative at this time of the night, which is now at 8:28. So we're going to have a one-term code. Mm-hmm. And I'm going to send Mr. Dealman, here 3. That's my message. My message is 3.
It has some significance to us.
It has
when
some
they're
significance to us, but that's a top secret. You can let me know what it is in a minute when we're all right. We have a one-term code and it is 3. We got this secret code function. We're squaring it. Shh. We're going to square it. So our coded message is 9 because 3 squared is 9. So Mr. Dealman sends me the coded message 9. You may think that the decoding function, i.e. our inverse function, would be the f inverse of x is the square root of x. So 3 coded it into a 9, decoding it into heck if I know. Why don't we just put 3 there? We know it should be 3, but here's the problem with our first example of something that does not have an inverse.
And you saw this with the last investigation. They asked you to decide whether or not the coding functions were good enough. And we gave you a couple of answers, and I think for part C on that one, it was a quadratic. And did we give them a graph? I think as a hint, we gave them the quadratic.
I think we gave them the graph, or we gave them the middle one was x squared, I think was the example from that. Yeah. So we're using it again.
Mm-hmm. So that's really trying to get at this idea that when you have, in this case, a quadratic, as you'll see in the picture, kind of the bottom center, you take the square root of 9, you're not guaranteed the 3. I mean, to us, it seems very obvious. We started with 3, we coded it to a 9, and we're going to decode it back to a 3 because that's the square root of 9. But just like when we're solving quadratics, we always forget to do plus and minus.
Oh, good point. Good.
When you're decoding, you can't forget about, in this case with a quadratic, plus and minus as a decoded term. So yeah, 3 squared equals 9, but
I guess
also, yeah, we got that. But also negative 3 squared gives you 9, right? You square a negative number, a negative times a negative equals a positive. So we've got a dilemma here. So
are we ready for the next slide, do you think?
Probably. I mean, at this point, we've decided, I mean, decoding right now is pretty tricky. So what's another way for us to explain it? So here we go.
Think that the graph, right? We gave the code, or the secret message was 3. We coded it by squaring it, and we got 9. Well, we drew a line through 9, and you should notice, please, that 9 has really 2 points of intersection with the red graph, and there they are.
Mm-hmm.
So to decode this, if I know 9 is my number, and someone tells me to decode it, I really don't know, should it be this number or should it be that number? There's 2 possibilities here. That's why, in order to have a good decoding function, we can't have multiple possibilities because no one will ever know what we're trying to say.
Mm-hmm.
Plus, if there's multiple possibilities, there is no decoding, which means there is no inverse function.
Yep.
F of x equals x squared does not have an inverse because it's not clear when I undo any horizontal line that I would draw through here. There's going to be 2 possible outcomes on every blasted horizontal line that we draw.
Mm-hmm.
We don't know which one it is.
And that's the big.
If we go back to, what was our function a minute ago? X plus 16?
Yes.
Right? I think we pictured that, did we not? There we go.
Fair enough.
So we had f of x was x plus 16. That was our coder. Our
Yep.
decoder, our inverse, was x minus 16.
And we said that in this case, f inverse of x equaling x minus 16, that is indeed the inverse of f of x, the inverse function.
Yep,
We kind of already decided that, right?
yep, yep. That's what the first lesson was kind of about. Now notice, gang, if I draw a horizontal line, if Mr. Dielman told me this is my number, and I don't know what that is on this graph, 'cause I don't know what the scale is. If I do
30.
this one, it looks like this is about 30. No,
Yeah.
20.
Yeah.
Okay. If he gave me 30, I would know what to do. I'd go, there's only one point of intersection here. It would be this X value would be the undoer of his Y value that he gave me.
Mhm.
And no matter what line I draw, that's only ever going to intersect the coding line, the coding graph, I should say, in one place. Whereas this coding graph of x squared, where did it go?
There we go.
This coding graph was x squared. I drew a horizontal line. He gives me the number that I got to decode. I got a problem, Houston. I don't know which one to pick because the coding message, the coder guy, gets hit twice by its number Mr. Dielman gave me.
So that's really the main point of, in this case, problems 1 and 2 of investigation 2. Does a function have an inverse function? Yes or no? And how do we know? So this is really the point we've tried to spell out to you guys here. And again, we say trying in simple terms, but obviously you might have questions. And so if you have those questions, obviously we're on our Google Docs during the office hours. So if you need a clarification, please post your questions there.
And I would like to maybe, Mr. Dielman, kind of solidify this even a little bit more. We didn't talk about this, but I think we need to. What functions have an inverse and how do you tell? This how you tell, we're going to call it run the vertical line test. Now, I'm dyslexic. Run, get out of there. Come on. Run the pencil, please. You can tell we didn't plan this. Run the horizontal line test.
Perfect. I was going to ask that before concluding. Should
the
we?
Horizontal line test goes like this. If the horizontal line that you draw intersects the graph in two places, it does not have an inverse. If it intersects it in one place, any horizontal line that I draw intersects the graph in the code graph in one place, then that code graph has an inverse. Horizontal line test.
Not to be
Here's your
confused
code line. Here's your code. Plus 16. It only ever intersects in one place. Thus, it has an inverse. So the horizontal line test is a really important thing, toolkitable. Can't leave home without it. What do you think, Mr. Dielman?
I'm running through the list in my head, and I think we covered it. At least what we planned to do.
All right. Well, just FYI for your information, we're at 1830. So you want to think outside the box here and just say, call it? I think that's fair. It's Friday tomorrow.
Yeah.
And if we talk a little bit longer, the parameter of 20 minutes, we could kill another couple minutes, and that's all they would really have to do.
Well, I mean, you figure in, and it takes them a minute or so to get it set up. And
then you say, you know what, they probably got to rewind the funnies because we were so darn funny. They were laughing. They wanted to hear them again. So they probably had to rewind a few times to keep laughing.
Yeah, at least a couple times.
All right. So I think, gang, we're both on the same page here of your assignment for Friday is to watch this video, and then we'll ask you some questions about it on Monday on a Google Doc from the next investigation. Mr. Dealman, it's always a pleasure. I always hate signing off because I always think that we forget something. But like you said, we're online 3 hours on Friday or
Yep.
Monday or Tuesday or whenever the day is.
And if we think of something, we can always create something in the spur of the moment. But I think we're good in this case. So.
All right, then Mr. Lemon is going to sign off. He's going to stop recording. See you all. Hope you're doing well.